Hello students, in this video let's discuss numerical solution of first order and first degree differential equation, means particularly initial value problems by Runge Kutta method of fourth order. This method gives more accurate value than previously we solved modified Euler's method and Taylor series method. Let's get started. First, let's understand the formula before solving the problems. We have the initial value problem in the form dy by dx is equal to f of x comma y. Initial condition y of x naught is equal to y naught with step length h. The task is to find unknown function of y at the given point of x. The Runge Kutta method finds approximate value of y for a given x. Only first order ordinary differential equations can be solved by using Runge Kutta method of fourth order, and we have the formula here to find that y1. So we are going to find y1 is y of x naught plus h, means x naught plus h means what? x1. Y of x1, this is given by previous y using the current y. What is current y? Y naught. The now new y is y1. So average of k values, k1, k2, k3, k4. So 1 by 6. If you take the total, this is also 6 times of the k values. So then what is these k's? The k values. Here it's given by the formula. And also we have the geometrical meaning of this k. K1 is the increment based on the slope at the beginning of the interval using y. K2 is the increment based on the slope at the midpoint of the interval. Next, K3 is again the increment based on the slope at the midpoint. Next, K4 is the increment based on the slope at the end of the interval. Okay, the formula given by K1 is h f of x naught y naught, and K2 is here f of x increment you are taking x naught plus h by 2 plus comma y naught plus K1 by 2. Then K3 is again h f of x naught plus h by 2, and these two are having same format, and every time you have to use the new k. When you are going to this k, there is no k as net yet found. When you are finding k2, k1 is available, so you have to give there k1 by 2. When you are finding k3, k2 is available, so y naught plus k2 by 2. Now k4 at the end, it is only just adding h and k3. And we can also observe in our formula 2 times k2, 2 times k3. That's why here we are taking divide by 2. So first one, last one, there is no divide 2 times at all. So therefore there is no divide by 2 here. So that's how you can calculate k1, k2, k3, k4, and finally substituting here, that gives us y1. Similarly, if you want to find y2, you find that y2 is y of x1 plus h, means nothing but y of x2. So now current y is y1. When you are going to find y2, current y is y1. So y1 plus same formula, average of k's 1 by 6 times of k1 plus 2k2 plus 2k3 plus k4. Where here k1 is calculated as, now the current values, when you are going to find the y2 value, current values are available are completely x1 and y1. These are values are available, pair. Okay, so taking that, k1 can be found as h f of x1 comma y1. K2 is h f of x1 plus h by 2, y1 plus k1 by 2. Next, k3 is h f of x1 plus h by 2, comma, y1 plus the new k is k2 by 2. At the end, k4, there is no divide by 2 in the formula. Careful, h f of just x1 plus h, y1 plus k3. This is how you can obtain k's value, and you substitute back to our formula, it gives us a required answer for y2. So let's get started with the problems now. Here we have the problem that employ Runge Kutta method of fourth order to solve the initial value problem dy by dx equal to 3x plus y by 2. And we have the condition y of 0 equal to 1. At what point of x we need y value? X is equal to 0.2 by taking h is 0.2. So first, by the given problem, we know that what is the condition and function given. So here from this you can take the function is what? Dy by dx equal to f of x comma y. Therefore, given f of x comma y as 3x plus y by 2. And from this you can note that what is x naught and y naught. So that is x naught is 0, y naught is 1. So now x1 is what? x1 is x naught plus h. Given h is 0.2, therefore x naught plus h is 0 plus 0.2, 0.2. At this point we require the y value at this point. So corresponding to this x1, you say that y is y1. So y1 is y of 0.2. That we have to find. Now, before that, we find all k's required. We find k1, k2, k3, k4. So that is, we have k1 is h f of x naught y naught, means h is 0.2, f of x naught is 0, y naught is 1. So therefore it is 0.2. We have the function f is what? Here 3x plus y by 2. So now we substitute in the place of x 0, 3 into 0, y is 1 by 2. So we get, on solving this point, this becomes 0, 0.2 by 2, 0.1. So where k1 is 0.1. Next we find k2, that is the formula h of x naught plus h by 2, y naught plus k1 by 2. Careful here. Substitute what is given h 0.2 and we find what is x naught plus h by 2. Where x naught is 0, h plus h by 2 gives 0.1. Next y naught plus k1 by 2. So y naught is 1, we have y naught is 1 plus k1 is 0.1 divided by 2. It gives us 1.05. So then substituting that is in our function given. So since f is 3x, where x is in our problem 0.1 plus y by 2. So 1.05 divided by 2. You consider this is x, this is y point. Then we calculate this. So that is the required k2. It is 0.165. 0.165. Next we find the next value, that is k3. Where k3 is the formula hf of x naught plus h by 2, y naught plus k2 by 2. Substituting for the values 0.2 f of, we calculated previous step itself, x naught plus h by 2 is 0.1. Now let us calculate what is y naught plus k2 by 2, where y naught is what? 1 plus k2 is 1.165 divided by 2. So that is 1.0825. Now substitute this in the function as x and y. This is x, this is y. We have the function is 3x, 3 into 0.1 plus y by 2, 1.0825 divided by 2. Next, do calculation. For this we get 0.16825. So we always get K2 and K3 almost near. And finally, we find what is K4. K4 is hf of x0 plus h, y0 plus K3. So we do calculation of x0 plus h is what? It is 0.2. H is 0.2 and x0 is 0. Y0 is 1 and K3 is 0.16825. Therefore 1 plus 16825. Now substituting this is in the function, we get h is 0.2, 3x 3 into 0.2, y by 2, 1.16825 divided by 2. So we get this is 0.236825. So we got all the k values, where k1 is 0.1, k2 is 1.165, k3 is 1.16825, K4 is 0.236825. Now what is Y1? So Y1 is Y0 plus previous. When you are finding Y1, we have to use the previous Y. Y0 plus 1 by 6 times K1 plus 2K2 plus 2K3 plus K4. Now we substitute for every K and Y0, where Y0 is 1 by 6, K1 is 0.1, K2 is 2, K2 is 0.165 and plus 2 times K3, it is 0.16825, finally K4 0.2368. So this gives the result on calculation 1.1672. So it means y of 0.2 asking to find, that is y of x1, it is 1.1672. This is our result. Let's solve another problem. Using Runge Kutta method of fourth order, we find y of 0.2 for the equation, differential equation, dy by dx equal to y minus x divided by y plus x, and we have the condition here y of 0 equal to 1, taking the step size h is equal to 0.1. Now first let us note down and how many stages it takes the problem, let us analyze. So initially the function x0 and y0 let us note down, where x0 is 0, y0 is 1. So from this you can note that x0 is 0, y0 is 1. Also it is given the function f of x comma y as y minus x, f of x comma y, given that y minus x divided by y plus x. Now how many stages? Only one stage, means only need to calculate y1, or is it required y2 also? It is all based upon yh value. Now let us define x1. x1, if you are getting 0.2, then it's a one stage. x1 you are not getting 0.2, we have to define x2. If you are getting this point, that's a two stage. First, x1 is x0 plus h, means it is 0.1. So y1 is y of 0.1. This is not directly required. Finally required y of 0.2. And for that we have to calculate this also. Means this is the first stage problem. First stage problem. Finding y1 is a first stage. Next we define x2. x2 is previous x. It is a 0.1 plus common difference of x is 0.1. It gives 0.2. So for this correspondingly you can write y2. y2 nothing but y of 0.2. So this is what we required finally. Okay, it means we have the second stage problem. So second stage problem you have to do. For that you can't do directly second stage, we have to go stage by stage. First stage, we calculate first stage, we find y1 is what? That is y of 0.1. Okay, for this we calculate k1. So f of x comma y is what are all required? Y minus x divided by y plus x, and x naught is required, where x naught is given in our problem 0, y naught is given in our problem 1. So using these values we just find k1, k2, k3, where k1 is hf of x naught, y naught. X naught, y naught means 0.1 f of 0 comma 1. So substituting, it is 0.1, 1 minus 0 divided by 1 plus 0, for it gives us 0.1. It's a k1 value. Next we find k2. K2 is h f of x naught plus h by 2, y naught plus k1 by 2. So it is 0.1 f of x naught plus h by 2, 0.05, y naught plus k1 by 2. 1 plus k1 is 0.1 by 2, it is 1.05. Then using the calculation in the function, so it is 1.05 minus 0.05 divided by 1 plus 0.5 plus 0.05. So on calculation this gives us 0.091. Next we find k3. It is h f of x naught plus h by 2, y naught plus k2 by 2. So it is what? 0.1 f of 0.05, and we have to find y naught plus k2 by 2. It is 1.0455. So therefore substituting this in the function, so 0.1, we substitute 1.0455 y minus x 0.05 divided by y plus x 1.0455 plus 0.05 based on the function. Okay, then this gives us now 0.0909. So see students, so k2, k3 always nearly similar. Next finally we find k4. K4 is hf of x naught plus h, y naught plus k3. So finding x naught plus h and k naught, y naught plus k3, it is a 0.1 f of x naught plus h, it is 0.1, y naught plus k3, it is a 1.0909. Next we substitute this in the function, that is y minus x, so that's a 1.0909 minus 0.1 divided by y plus x 1.0909 plus 0.1. So we have here x and y, so that we substitute. On calculation this gives us 0.0832. Now after finding all case value, we find what is y1. So y1 is y naught plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. Next we get that where y naught is 1 by 6, we got k1 is 0.1 plus 2, k2 is what? K2 is 0.091 plus 2 times k3 is 0.0909 plus k4, it is 0.0832. So doing calculation we get approximately 1.0911. So this is y of 0.1. So finally required y of 0.2. So y1 we have this y, keeping this y1, and next for the next stage let us go find y of 0.2 is what? That is y2.